Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. On the behalf of Divisional Public School and College Sahiwal, I welcome you all in the online classes. I am Amna Sadiq, working as subject specialist in mathematics at Divisional Public School and College Sahiwal. Today, we are going to discuss about solving quadratic equations by completing square method. So, what is a quadratic equation? An equation consisting of the polynomial of degree 2 with a single variable is called quadratic equation. The general form to describe a quadratic equation is ax square plus bx plus c equal to 0. In this equation, ax square is called the quadratic term, bx is the linear term, and c is the constant term. In this equation, a should not be equal to 0 and a, b and c are real numbers. A is called the coefficient of x square, b is called the coefficient of x, and c is the constant term. In this quadratic equation, if we put a equal to 0, then it reduces to a linear equation bx plus c equal to 0. And if b is equal to 0, in ax square plus bx plus c equal to 0, then the quadratic equation becomes a pure quadratic equation with the terms ax square plus c equal to 0. There are three methods to find the solution set of a quadratic equation. The factorization method is the first method which we have already discussed in the previous lecture. By completing square, which we are going to study today, and by quadratic formula, which will be discussed in the next lecture. Completing square method proceeds in 5 steps. First of all, you have to check the coefficient of x square. If a is not equal to 1, then we divide the whole equation by a. Then we write the new quadratic equation in the form x square plus bx equal to c. That is, we take the constant term from left hand side to the right hand side. Then we add b over 2 the whole square on both sides of the equation to complete the square on the left hand side. After this step, you will see that the left hand side of the equation forms a perfect square. X plus b over 2 the whole square is equal to c plus b over 2 the whole square will be the new equation. Taking square root on both sides and then solving it for x, we get the solution of the quadratic equation. Our today's task is to solve question number 3 from exercise 1.1. For this purpose, I am solving a few questions for your understanding. For the convenience, I am displaying the steps and the solution side by side. First of all, look at the equation. Here the coefficient of x square is 7. So, we divide the whole equation by 7. As a result, we get x square plus 2 by 7x minus 1 over 7 equal to 0. Then we arrange the equation by taking the constant from left hand side to the right hand side. As a result, we get a new equation x square plus 2 by 7x equal to 1 by 7. In this equation, b is equal to 2 by 7. So b over 2 will be equal to 1 by 7. And b over 2 the whole square is equal to 1 by 7 the whole square. Adding 1 over 7 the whole square on both sides of the equation, we get x square plus 2 by 7x plus 1 over 7 the whole square equal to 1 by 7 plus 1 by 7 the whole square. As we can see that the left hand side of the equation makes a perfect square. So x plus 1 over 7 the whole square is equal to 1 over 7 plus 1 over 49. Taking the square root on both sides of the equation, we get square root of x plus 1 over 7 the whole square is equal to square root of 50 over 49. This fraction 50 over 49 can be obtained by taking the LCM of 1 over 7 plus 1 over 49. Square and square root will cancel each other and we get x plus 1 over 7 equal to plus minus 2 square root of 2 over 7. We get this term 2 square root of 2 by taking the square root of 50. This plus minus tells us that x plus 1 over 7 has two values. Either it is a positive 2 under root 2 over 7 or a negative 2 square root of 2 over 7. Then, solving these equations for the value of x, we get x is equal to minus 1 plus 2 square root of 2 over 7 or x is equal to minus 1 minus 2 square root of 2 over 7. These values of x can be obtained by taking the LCM The value of x can also be written as minus 1 plus minus 2 square root of 2 over 7. This is called the root or the solution of the equation. And we can call it the solution set. The solution set can be written as the value of x enclosed in the braces. Now let's move to our next question. 3x square plus 7x equal to 0. Here we can see that the coefficient of x square is 3. So we divide the whole equation by 3. As a result, we get x square plus 7 by 3x equal to 0. We can see that the equation is already arranged. So the value of b is 7 by 3. When dividing it by 2, we get b over 2 is equal to 7 by 6. And on squaring, it will become 7 by 6 the whole square. Adding 7 by 6 the whole square on both sides of the above equation, we get x square plus 7 by 3x plus 7 by 6 the whole square equal to 7 by 6 the whole square. Writing the left hand side of the equation as a perfect square, x plus 7 over 6 the whole square, which is equal to 7 over 6 the whole square. Taking square root on both sides, we get square root of x plus 7 over 6 the whole square is equal to square root of 7 by 6 the whole square. The square and square root will cancel each other and we get x plus 7 over 6, which is equal to plus minus 7 by 6. This plus minus tells us that x plus 7 over 6 has two values. Either it is a positive 7 by 6 or a negative 7 by 6. Now solving it for the value of x, we get two solutions. Either x is equal to 0 or x is equal to minus 7 by 3. Writing it in the solution set, we get 0 and minus 7 over 3 enclosed in the braces. Now for the next question, we have an equation which is not arranged in the general form of the quadratic equation. To arrange it, we multiply it by 3x plus 1 on both sides, or we can take the LCM of the given equation. Multiplying the equation by 3x plus 1, we get 4 times 3x plus 1 minus 8 equal to 3x square plus 5. The other values will cancel each other. When multiplying 4 by 3x, we get 12x. When multiplying 4 by 1, we get 4 minus 8 equal to 3x square plus 5. Rearranging this equation in the general form of the quadratic equation and solving it, we get 3x square minus 12x plus 9 equal to 0. Since the coefficient of x square is 3, so we divide the whole equation by 3 and get x square minus 4x plus 3 equal to 0. Rearranging this equation, we get x square minus 4x equal to minus 3. We take the constant value from the left hand side to the right hand side. Here we can see that the value of b is 4. When dividing this by 2, we get b over 2 equal to 2. So adding 2 square on both sides, we get x square minus 4x plus 2 square equal to 2 square minus 3. The left hand side of the equation makes a complete square, so we can write it as x minus 2 the whole square, which is equal to 4 minus 3, or x minus 2 the whole square is equal to 1. Taking square root on both sides, we get square root of x minus 2 the whole square is equal to square root of 1. This 2 and the square root of 2 cancel each other and we get x minus 2 equal to plus minus 1. Which means that x minus 2 has two values, either it is equal to positive 1 or negative 1. Solving it for the value of x, we get x is equal to 3 or x is equal to 1. Writing it in the solution set, we get 1 and 3 written in the braces. Now look at our next question, which is minus x square plus 15 by 2 equal to 7 by 2x. This equation is not arranged as a general form of quadratic equation. So firstly we arrange it. After arranging, we get x square plus 7 by 2x minus 15 by 2 equal to 0. In this equation, the coefficient of x square is already 1. As we can see that the coefficient of x square is already 1. So we arrange the equation by taking constant from left hand side to the right hand side. As a result, we get x square plus 7 by 2x equal to 15 by 2. In this equation, b is equal to 7 by 2. So dividing it by 2, we get 7 by 4. And squaring it, we get 7 by 4 the whole square. Adding 7 by 4 the whole square on both sides of the above equation, we get x square plus 7 by 2x plus 7 by 4 the whole square is equal to 15 by 2 plus 7 by 4 the whole square. Writing the left hand side as a complete square, we get x plus 7 by 4 the whole square equal to 15 over 2, 49 which is the square of 7 and 16 which is the square of 4. Taking square root on both sides, we get square root of x plus 7 by 4 the whole square, which is equal to square root of 169 over 16 the whole square. This fraction 169 by 16 can be obtained by taking LCM of 15 over 2 plus 49 over 16. The square and square root cancel each other. As a result, we get x plus 7 by 4 equal to plus minus 13 by 4. Which means that x plus 7 by 4 has two values. Either it is positive 13 by 4 or negative 13 by 4. Solving these equations for the value of x by taking their LCM, we get x is equal to 3 by 2 or x is equal to minus 5. Writing these values in the solution set, we get minus 5 and 3 by 2 enclosed in the braces. Now, our next question is ax square plus 4x minus a equal to 0. As this is a generalized question and value of a is not mentioned, so we assume that a should not be equal to 0. Dividing the coefficient of x square, dividing the given equation by the coefficient of x square, that is a, we get x square plus 4 over ax minus 1 equal to 0. Rearranging this equation, we get x square plus 4 over ax equal to 1. We take the constant, we move the constant term from left hand side to the right hand side. Here the value of b is equal to 4 over a. So b over 2 is equal to 2 over a. And squaring them, we get b over 2 the whole square equal to 2 over a the whole square. Adding this 2 over a the whole square on both sides of the equation, we get x square plus 4 over ax, 2 over a the whole square equal to 2 over a the whole square plus 1. As we can observe that the left hand side forms a complete square, so we can write it as x plus 2 over a the whole square, which is equal to 4 over a square plus 1. Taking square root on both sides, we get square root of x plus 2 over a the whole square equal to square root of 4 plus a square over a square. The square and the square root cancel each other and we get x plus 2 over a equal to plus minus square root of 4 plus a square over a. Which means that x plus 2 over a is either equal to square root of 4 plus a square over a, or x plus 2 over a is equal to minus square root of 4 plus a square over a. Solving these two equations for the value of x, we get x equal to minus 2 plus square root of 4 plus a square over a, or x is equal to minus 2 minus square root of 4 plus a square over a. Or we can write it as x is equal to minus 2 plus minus square root of 4 plus a square over a. We can write the solution set as the value of x enclosed in the braces. Now, we summarize our today's lecture. The quadratic equation is an equation consisting of the polynomial of degree 2 with single variable. The general form or the standard form of the quadratic equation is ax square plus bx plus c equal to 0. In this equation, a should not be equal to 0 and a, b, c are the real numbers. If we put a equal to 0 in this quadratic equation, ax square plus bx plus c equal to 0, then it reduces to a linear equation, bx plus c equal to 0. If b is equal to 0 in ax square plus bx plus c equal to 0, then it is called a pure quadratic equation, and we can write it as ax square plus c equal to 0. This equation remains pure quadratic equation if c is also equal to 0. There are three methods to find the solution set of a quadratic equation. In factorization method, we break the equation into its factors and solve it for the value of x. In completing square method, we complete the square of the equation on the left hand side and then take the square root and solve for the value of x. In the next lecture, we will discuss about the quadratic formula for finding the solution set of a quadratic equation. There are some points to be remembered while understanding these methods. If you have an equation of the form 5x square equal to 30x, then we cannot cancel x on both sides. Cancelling x on both sides means we will lose one root, that is, x is equal to 0. Instead, we take 30x from right hand side to the left hand side, and taking x as a common factor, we get x equal to 0. And in completing square method, when we make the coefficient of x square equal to 1, it is just for our convenience. The quadratic equation can always be solved without this step. Dear students, I hope you understand our today's lecture. Now it is your home task to solve the remaining parts of question number 3 from exercise 1.1 and solve example number 1 and 2 on page number 3 and 4. For your better understanding, please look at these equations and separate the standard quadratic equation and pure quadratic equation. The first one, 3x square minus 12x plus 4 equal to 0, is a standard quadratic equation. That's all from today's lecture. Thank you very much.